This video is about fractional exponents, and it's important to have some background on how to just do the laws of exponents first, but we've already done that, so this is just kind of just another aspect. So first up, whenever you see a fractional exponent, this is referring to some type of root. So when the denominator, when the denominator is 1/2, this is going to be a square root. If the denominator is 1/3, this will be a cubed root, and make sure you put it there in front of instead of outside, because then it would mean 3 times the square root. If it's the denominator has a 4 in it, then you would put a 4 there, meaning the 4th root, and so on. So writing this one here, I could just rewrite this as the square root of 16, which means what number times itself gives you 16, which is 4. So now let's take this and look at this next problem here, where we've got 27 to the negative 1/3. So as I kind of go, it's like whenever you see a negative exponent, so the negative exponent has nothing to do with whether the number is positive or negative, but I always think about when you see a negative exponent, think location, location, location. So this number here has a negative exponent, so 27 over 1. And the reason I'm putting it over 1 is because when you see a negative exponent, it means the location of this number can actually be written in the other place. And so when I'm gonna rewrite this, and so instead of 27 over 1, this is now, the 27 is now in the denominator. And when you change the location, you also have to change the sign of the exponent. So this now becomes positive 1/3, and this 1 up in the numerator is basically your kind of placeholder. So I'm just taking this fraction 27 over 1, inverting it, now it's 1 over 27. Now, the next piece is we're going to be looking at, like, this whole thing is taken to the 1/3 power, and we talked about 1/3 means cubed root. Well, I could write it this way: cubed root of 1 and cubed root of 27, because each piece is getting that. Well, what number times itself 3 times gives you 1? That's 1. What number times itself 3 times gives you 27? So that's 3. 3 times 3 is 9. 9 times 3 is 27. Okay, so there's your answer for 27 to the negative 1/3 power is 1/3. Okay, next one. So here we have 4/9, the quantity 4/9 to the negative 2nd power. Once again, when you see that negative exponent, location, 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 this means you could rewrite this where you've changed the location. So 9 now goes in the numerator, 4 is in the numerator, it has a negative exponent, we're going to switch it to the denominator. And when you change the location, you change the sign of the exponent, so now that's positive 2. And I could write this, I could think about this as a couple ways. I could think about this is 9/4 times 9/4, or 81 over 16. The other way you could write this is you could also say this is 9 squared and also 4 squared, and you get back to the same thing when you simplify it, which is good to see it more than one way. And I think that's going to be one of the tricky parts of this section, is that there's more than one way to approach these, but it's really about being systematic and showing your work. So this one here is 4 over 81 to the 3/2 power. Now, I could think about this in 2 ways. One is this is 4 over 81, and I'm going to rethink about 3/2, because I'm like, whoa, I can know how to do a square root of a number, but I don't, because once again, a fractional exponent talks about root. But what happens when there's a number up on top of it? That kind of can just mess with you. So we've learned in our laws of exponents that when you take exponent and you raise that to an exponent, you multiply those. So exponent to an exponent, 3 times 1/2 is 3/2. So this is one way to rewrite this. And I'm putting the parentheses because this 3, this cube, goes with the whole fraction. So I'm using parentheses and then brackets here. The other way I could do this is I could go 4/81, and I could say this is to the 1/2, and this whole quantity is cubed. And once again, an exponent to an exponent, multiply those. 1/2 times 3 is 3/2. So these are all equivalent expressions. Now, some of these are going to be easier to simplify than others. Now, one way you could do this is you could go 4 to the 3rd power, 4 times 4, 16 times 3, 64, and then take the square root of that. Okay, so 4 times 4, 16 times 3, 64, and then I'm going to take, that's going to be to the square root. And then I'm going to do the same thing, 81 times 81, and this is where like you would probably want to get a calculator out. Okay, so 81 times 81 is 6,561 times 81 again. Yikes. Really super big number. And this is also going to be square rooted. So I could have written this also as the square root of 64 and the square root of that like ridiculously large number. So the square root of this is 8, and the square root of the other one is 729. So those are kind of big numbers to deal with. Definitely want a calculator for those. Hope your teacher lets you use them. Okay, now the other way, I like this way a little bit. I think it's a little easier because you're going to basically be doing a square root first and then cubing the number. So I'm going to just kind of rewrite it because I like to do the square roots this way. Square root of 4 over square root of 81. And then this thing, I'll stick with the brackets just so you can kind of see where I'm at. So this here is a square root of 4, square root of 81. So I've just rewritten it. And this is all being cubed. So square root of 4 is 2. Square root of 81 is 9. And this is all going to be cubed. 2 cubed means 2 times 2, 4 times 2 is 8. And then I have my next piece here, which is 9 to the 3rd power. So that's 9 times 9, which is 81, times 9, which is 729. Hopefully not a big surprise there. So you can do it either way. I personally think it's a lot easier to do square roots or cubed roots first, so you're getting the number small, and then you might actually not need to use a calculator. So if your teacher doesn't let you use a calculator, then you definitely want to go with that second route there. Now, this last one here, it's got a couple pieces to it. So once again, I'm going to deal with the negative first. So I like to deal with, so this is my approach, and there's more than one right way to do it. So I like to deal with the negative exponent first. Once again, I see a negative exponent, tells me location, location, location. So I'm going to rewrite this fraction. Instead of 1 over 9, it's going to be 9 over 1. So I've changed the location, I changed the location, I changed the sign now to 3/2. As I said, you can write this more than one way. 9 over 1 times to the 3rd power to the 1/2 power. So 3 times 1/2, 3/2. I could also do this 9 over 1 to the 1/2 cubed. So I'm going to go with the second way. So the square root of 9 is 3. That one doesn't change anything. And then I'm going to cube that, which is 27. Sorry, I'm having to cut it out because we're running out of time on YouTube. So good luck with that. It really is about practicing. Check out some of the other resources.